Uh, Hello everyone. Today we will start model the cantilever beam using 3D solid elements. This actually is exactly the same problem. The length of the cantilever beam is 1200 and 50 millimeter is width and the height is 100 millimeter. So we up to now we model using beam element, we model using stress element, plane stress element, shell element, and today we will use a solid element. The solid element use an ABAQUS called uh, a 20 node break elements C3D20, which is available in ABAQUS. So 20 noded break element. We will have to subdivide or mesh into 16 element I've seen here. Here we need to find out what is vertical displacement over AB and also the stresses over AB. And finally we need to compare between numerical and analytical analysis. Let's start with ABAQUS as usual. So I really open it here, and then before I start I must go and set directory, work directory into somewhere, and then I will choose, for example, like ND, and then I have to go ABAQUS, and then okay. So everything will be saved in this file. Yeah, I created that file before, and then okay, and then okay. Now to start the model, let's go to part, and then we go to manage part manager, and then in the part manager we need to create. Let's call it as a beam and a 3D and solid and extrusion, and then after that we said continue. Now what we will do is we will draw A, B, C, D and extrude it by 50. So the coordinate of A, B, C, D is start from 0, 0, enter, and then 1200, 100 in Y direction, comma. Now if we go into auto fit view, we click there, and then we cancel procedure to say that is done, and then we say done for extrusion. Now it's extrusion in a width of the beam as you see here, so it's extruded in 50. So it is 50, and then you said okay. Now we create that beam. Now we close this. We go to property. Now we need to create material with elastic material, and then you go to material manager. We create material. Let's call it as a steel material. We go to mechanical, elasticity, and elastic. The material is 100,000 in Newton per millimeter squared and 0.25 Poisson ratio. I said okay, and let's dismiss. Then we have to go into section manager. We go to create. Let's call the section as a beam section, homogeneous, solid, and continue. We keep it as it is. We don't tick this about at all because it's a solid element, 3D solid element, and then okay, we dismiss. Now we create the material and we create a section. Now you need to assign that beam into that section. You go to section assignment manager, you go to create, you click on the beam, and you said done. You need to accept everything because this section, if you read it, this is section beam section and the material is steel, and then done. Okay, and dismiss it. Save. Let's save it as a 3D solid element, and then okay. Then you go to assembly. You notice you don't see anything. The model is not there. You go into create instance. You end up with a beam independent to mesh on an instance. And then okay. Then you bring that beam. And then you go to step. You go now to step manager. Create. We will choose static general. And then continue. You accept the default and you said okay. This step is important to create a load step and then dismiss it. You go into loading. Now, in this loading, let's define a boundary condition or boundary condition manager and then create. Let's just call it as boundary or fixed. Or fixed boundary condition BC. Okay. And let's choose displacement rotation and then you continue. Move this aside. It will ask you where do you want to apply the boundary condition. I will apply the boundary condition on that bottom surface, so I cannot just divide this rectangle here in the bottom surface, or not bottom surface, is the back surface, that back here in ZY. So what I'm gonna do, I will go to rotate view and then press on your left button in your mouse and move. Okay, so you move it. To cancel the procedure of the rotation, you click here, cancel procedure. Only one click to cancel the previous procedure with the rotation. Now we'll ask you what is the region to boundary condition. You said this one. Now you can see it. And you said done. Now you set up everything to 0 to represent everything is fixed boundary condition, as you said okay. If you want to rotate back, you go into rotate view and rotate the whole element again. You can zoom in and zoom out by moving your mouse wheels. And then it's moved as this. You justify it. To cancel the rotation procedure, we still have this circle in this view. What you have to cancel the procedure. Done. In order to apply a load, you will go to load manager and then you create, let's call it loading, and we will use here concentrated force and you continue. Now the question is, where do you want to put the concentrated force? I want to apply the force here. Since we have two nodes here, one node here and one node here, we don't have motors in the middle. So what I will do, I will apply a total, the total load is 10 kilonewton. So I will apply on this node 5 kilonewton and the other node 5 kilonewton, so total will be 10. So now what I'm gonna do, I will click on this node and then I press shift in your keyboard and you press the other node. So you can now choose multiple nodes and you say done. Now we need to apply a load in perpendicular to the beam and it has to be in the y direction. Since y is up, as you see here, therefore it has to be, the load has to be negative. We are using Newton millimeter, so it is minus 5,000 Newton. 5,000 here and 5,000 there, so it will be 10,000 Newton down. I said okay. You see the arrow, it goes down and dismiss. Save. You go into mesh. Notice a little bit tricky part. The tricky part of it is the mesh, you need over the length of the beam, you need 8 pieces of mesh. 1, 2, 3, 4, 5, 6, 7, 8. So how are you gonna do that? You go into seed edge. Now I don't need to click each of these edges. I could click all of it by making a window. So you press on the left button of your mouse, you create a window, and this window will interact with these edges of the beam, and that's it. It's like you are doing that in AutoCAD. So you will notice these are highlighted. So mean that you locate them and you say done. By number, I need 8 pieces, and you said okay. You will notice you will have now 8 pieces. Now the other side is I need these pieces. I need 2 pieces here, 2 meshes. How are you gonna do that? I could do that is I would yeah, is an easy way. If instead of going now to collect each edges 1, 2, 3, 4 somewhere, we could collect them differently simply by press on this axis X. You will notice that is rotate. So it means, let's go rotate it back and cancel the procedure. It means that when you press on X here, it means that you will have the X-axis perpendicular to YZ plane. If you need, for example, if you press on a Z-axis, you will see that rectangular. If you press on Y-axis, you will see the top of the beam. X-axis, you will see that shape. Now, you notice this is the that's a view, so you need the full rectangle. So you press on turn perspective off. So we have this turn the perspective on. This is on perspective. Now by turn it off, you will see the whole vision. And then you can, by click the seed edge, you can highlight only the vertical lines, and if you go and rotate it, you will notice that these lines are these lines are selected, and let's cancel procedure for rotation. Now we say done, and by number we will choose 2 elements, and then you say okay, and everything will be done. Now let's mesh the part. So we go to mesh part instance, and you said okay, yes. Now we've got 80 element, 60 element. Now we need to choose the name of the element. So you go to assign type, element type, and you click on that beam, and you said done. Now what you need a quadratic and anti-reduce integration. Please go and read about reduce integration. So we will use 20 noded quadratic break. That's what we are looking for. And then you said okay, and then done. Now go to job to run the model. You go to job, create, keep the name as it is, continue, and okay, accept everything, and then submit the job and wait until finish. to submit it. It's running now. Now it is completed. Let's get the result out of it. To show the deformed shape, you click on contour plot form shape. Now, I'm looking for deformation over AB here, displacement, which is in Y direction if you look at here. So you need to go to U and then you choose U2. Let's find out the path over that link. So we go to Tools, Path, Manager, and then you create and continue and add after. You click here, you click in the middle because it's 20 noded, you click here, you click, and you continue. Data path, and you say done, and then OK. We've got the path, and now we need to find XY data, manager, create, path, continue. Now this is a path, it is undeformed, and that path is in X direction, so it distance X. Make sure it is U2 and save as. By double click, you will have displacement distances and the corresponding displacement, and you go to here and you fill up the table, this table for displacement, vertical displacement, table number 1. Now it's okay. Now I'm looking for S11, which is the bending stress. Now, which is at the same path. S11 is the same path. What you can do, you can only change the field output by click on the field output in the XY data from path. You go to stress components and you click S11 and you said OK. Now it's a change to S11 and also he changed to S11, and you save everything and OK. Double click, you will see the distances and the bending stresses. You copy these bending stresses and you put it in this table. Now after you finish, you need to plot bending stresses, deflection, and compare with experimental value and make comment on your graph. Then OK, and close, save your model, and that's done for today. Have a nice day.